holding the prestigious World Heritage Monument status awarded by UNESCO. Built in the early 18th century by Raja Sabai Jaising II of the Kachwaha dynasty, the structures here are striking to behold, with unmatched degree of accuracy of the instruments. The observations and derived calculations are still used for many purposes, including astrological predictions and making of the common astronomical calendar. This presentation is to brief you on the working principles of some of the instruments that you could see today. The journey to the making of this observatory began in the year 1790 in the court of the Mughal Emperor Muhammad Shah, where it was felt that to accurately predict the auspicious time for state functions, it was necessary to make home astronomical tables and therefore to build an observatory, with the understanding that Jaising was a learned man with deep passion in astronomy and mathematics. The emperor assigned this to Jaising. The location was decided to be in the Raisina forest of Delhi. Jaising initially began by constructing metal instruments, but he soon decided to make large-size instruments of masonry and stone, adapting the style of the stone instrument observatory at Samarkand, built in the 15th century by the astronomer King Ulugh Beg. With this meticulous planning, aided by the study of documents from the West and experiments that he carried on at a secret place of Talkatura Lake near Amer, Jaising not only made the observatory in Delhi, but also made one at Jaipur, followed by others in Varanasi, Ujjain and Mathura. There are indications that he also extended the use of his findings to mark his new capital, now Jaipur, precisely aligning the axis of the palace with the direction of celestial north. This observatory at Jaipur houses more than 18 functional instruments, some bearing a stamp of his intuitive mind. Before we go into the details of the working of these instruments, let us first understand the principle of a simple sun dial. During the day, any shadow on the earth moves according to the position of the sun. In the morning, when the sun is in the east, the shadow falls in the west. At noon, when the sun shines exactly over the head, the shadow is right beneath us. And when the sun moves in the west, the same shadow extends towards the east. If this shadow is projected on a circular strip such that it moves at a steady pace, one can easily find out the time of the day from sunrise to sunset through set calibrations on the scale. This principle has been followed here in the Lagu Samradhya, with the understanding that larger the scale, higher is the accuracy. Jaising ventured into making this greater Samradhya that gives an accuracy of up to 2 seconds. Observing carefully, one would find that the flight of stairs of this brilliant Samradhya points towards the pole star in the north, establishing the principle that the direction of the stairs is parallel to the north-south axis of the earth. If the curved calibrated sundial of this instrument is completed, it would form a circle with the stairs in the middle of it. Extending further, it can be inferred that this instrument is a replica of our Earth, with the angle of the inclination of the stairs indicating the geographical latitude of the place on the Earth where the instrument is located. In Jaipur, the inclination of these stairs is 27 degrees, and on Earth, Jaipur's latitudinal angle is 27 degrees. Imagine the Earth to be in the middle of a large spherical balloon of stars called the celestial sphere. This model gives us immense understanding of the celestial sphere and the significance of zodiac signs. The zodiacs lie on an imaginary belt around the Earth, dividing the sky into 12 equal parts, each corresponding to a zodiac. The zodiac signs can be seen in the night only, and the ones that are visible are those that lie on the opposite side of the sun's position on the bed. The remaining ones masked due to the bright sunlight. During the year, while revolving around the earth, the sun also moves in front of the zodiac signs with the previously hidden signs, revealing themselves one after the other, marking the completion of any month during the year. Also, the measurement of which gives us an accurate indication of the sun's position. The instrument has two scales. On one scale, the direction is measured from the north, and on the other scale, the height is measured from the ground. On these flat surfaces, the shadow does not move at a uniform pace. If these surfaces were curved, speed of the shadow would be constant, and the scales for height and direction would also be continuous and uniform, making the readings more accurate and easy. As if Jantar was to be an experimenting launch land, Jaipur extended the principle of measurement of Jantar into making another unique instrument, Jantar, named after him. If you extend the understanding of the celestial sphere, you would find that each Jantar is a model of the celestial hemisphere, which, when completed, represents the celestial sphere, with the dome representing the earth, situated in the middle of the celestial sphere. The calculations done with the help of this instrument reflect the actual position of the celestial sphere, as if it was turned upside down and placed on the earth. Like the round, this has been divided into two parts, each complementing the other. Jaipur is all-inclusive instrument of Jantar, which helps us in making many observations simultaneously. It would be logical to affirm that the qualities of other instruments like Samrat Yantra, Rakshibai Yantras, and Ram Yantra have all been integrated in this yantra. We hope this